Okay, for 302 compilers. Okay. Just go over some administrative issue before we talk about some motivation for today. Today is going to be very light and give you some motivation about the overall. Okay, many of you know me. Call me Jackie, and then other title will be fine. And then office hour this term, Monday, Wednesday, 3 to 5 p.m. If you cannot make to the hours, send me an email to make appointment. That's absolutely fine. Okay. And if you need advice, speak to me. And then also, it's going to be a small class. I'll teach it like a big class, right? But if you really want me to change the way I teach, let me know. If you think that might be more useful, that's fine. The only rule, only one person talking at a time, please. Okay? But feel free to interrupt me for discussion. Not a problem. Okay. And I'm going to put everything available to you for study. Okay? I record every lecture. I'll try if the technology doesn't fail. So if you go to my website over there, okay? Let me make it a little bit smaller. Okay, you will see there's a link over there for 4302. Okay, I'm gonna put lecture slides, recording for the lecture, and also the written notes, and any source code that we have to go over, everything here. Okay. There will be a Moodle. There's a Moodle site over here. It's mainly used for announcement. Okay, I'm actually going to make the assignments and project available on the Moodle as well, so it's only available to you. Okay, and then there's also a Q&A forum. You can also post questions. Okay, so mainly for these purposes. Later tonight or tomorrow, I'm going to upload the syllabus, which we're going to go over as well, a PDF over there, so we can also go over. Check your emails regularly, please. I think you should have got one message from me maybe yesterday about the textbook, right? Okay, I'll talk about it. Okay. Oh, I forgot to bring the copies. Okay, I'll bring it next time. So you can, if you are interested in looking at the copies, let me know. I also put a request for reserve for the textbook on the library. So I'll talk about it. Okay, so, if you're not enrolled yet, if that's the case, send me your information and I'll add you to the Moodle before you can get into the course, just in case. Course syllabus will be on the Moodle side, but I will talk about it. Okay, let me talk about the course syllabus. That might be a good idea. Okay, just see how the course is going to be run. Okay, there's some course learning outcome not here. Sorry, this guy here. Okay, this PDF will be made available later today. Okay, syllabus information, office hour, I talk about it, and also prerequisite. Now, let me make sure every one of you took 2001. Automata, grammar, right? But we have to review those topics as well. But I would say this course is I think it's a must-take after you have suffered this theoretical foundation for 2001. And this is quite a nice course to see the practical implication for those theories. So we're gonna have fun. Okay. 2001, but don't worry. Once you get a textbook, get a course notes, study them, ask me for questions. But we're gonna review them for sure. Briefly in the course. Okay, for the course description, you can take a look. This might be slightly different from what you will see on the register website. So this one is being approved by the department because, as I said, the last time this course was offered was back in 2005, and nobody was interested in teaching it. Funny enough. Anyway, but we're gonna make some history here. Okay. Okay, course learning outcomes. I'll talk about it. A little bit later. Okay, so just 5 course learning outcomes for the textbook. Okay, the one I'm going to follow rather closely is this particular textbook. It's called Engineering a Compiler. Okay, so you can go to the publisher's site to actually see more information. Okay, it's not 100% required, but it will be very useful if you buy it. So anytime if I miss some details from the textbook in the slides. Maybe I will focus more on examples during the class. Any theory that I might refer you to in the textbook, you should read them. Okay. There is another book, the so-called Dragon book. It's actually very conventional text for compilers. So this one absolutely optional, but you can also check it out from the library. Okay, that one also can be useful for some theoretical stuff. You can also look at that. So 2 books. Okay. You can either get an electronic copy, you can get a hard copy. That's okay. Okay. All right, and then grading scheme. Okay, so we are going to have 5 in-class quizzes, okay? In principle, they will be on Mondays on a bi-weekly basis. So rationale, I want to encourage you to come, and more importantly, I want to encourage you to study steadily. I don't want you to stay behind, okay? The quizzes will be about 15 minutes each in the beginning of the class. Okay, I'll also show you the schedule for the quizzes. Okay, I'll get there. So it will be 5 of them, and then 4% each, so 20%. And also we got the exam at the end. And also we got some programming exercises over here. We got 4 assignments, and they are more related to the example that we talk about in the class. So you can actually practice that. It will be very nice preparation for the eventual projects, and that'll be 30%. Okay, that's going to be a grading scheme. Okay, any questions? Yes. I think for project, for sure, most likely group basis. Yeah, I think because it might require quite a bit of work. So I think group project might be better. Okay. But for assignments, I think for now, tentatively, I would say individual work. I'll be 100% precise when I release the instructions. Yeah. Okay, and standard cutoff for the letter grades. Okay. And tentatively, we're going to cover these topics over here. For today, I'm going to just talk about overview for compilation and give you some examples just to see how powerful compiler could be. Okay. And also, we're going to talk about different analysis at different levels for compilation. We'll talk about them. And also, and we're going to use a tool called Antler. I'm not sure if any one of you has used it before. It's actually a very popular tool for doing parser generator. Okay, we'll talk about it. So maybe I will dedicate maybe 1 or 2 classes just to do some in-class tutorial to help you get started with the tool so you can get some practical experience. Okay, but we'll get there. Okay, you don't have to worry about Antler until I release the first assignment or if I notice you earlier. For now, you don't have to worry. Okay. And then we're going to talk a little bit more about intermediate representation optimization. So these will be more advanced topics, maybe after the reading week. Before the reading week, we're hoping to at least cover these. Okay. Tentatively, so these are the agenda for you to be aware of. Okay. As I said, for the quizzes, it's going to be bi-weekly basis. So for now, unless otherwise noted, okay, your first quiz will be January 20th in the first 15 minutes. Okay, just show up in time and then get prepared. Okay, the quiz will actually cover basically just what I talk about in the class, mainly the slides. If there's any particular section I would like you to read from the textbook, I'll let you know. Okay, yeah, I'll make sure you are properly informed about what should be covered. Yeah, because it's about 4% each, right? So you got to be careful. Okay, for now it's going to be bi-weekly basis for 5 quizzes. Okay, tentatively we're going to let you start doing assignment number 1 from week number 3. Okay, I'll say roughly speaking about 2 weeks per assignment, roughly speaking. Okay, I'll set some deadline accordingly. And then for the projects, it's going to be taking more time. I'll try to release it maybe either week 5 or week 6, definitely before the reading week, so you got enough time to get started and then complete it until the end. So that would suggest at some point in the semester, you may have to somehow worry about quiz number 4, some assignments and projects unavoidably. Okay, I just want to warn you because I do have concern. Okay, please be aware of that. Okay. But it should be okay. Quiz is only in class, right? It's not going to be taking that much of your time. Okay. Guys, any questions until now about grading scheme, just overall? Okay. All right. Apart from that, I'm just going to go finish the slides over here. Okay, in-class quizzes, first 15 minutes. We'll see how that goes for the first one. If we find out you need a little bit more time, extend it to 20 minutes. We'll see. Okay. Okay, so if you really miss a quiz, given that you got valid documentation, I may shift the way to the exam. There'll be no makeup quizzes. Yeah, because that means they'll force me to give you different questions, which would be difficult to make sure it's fairly similar to the previous one. Okay, just for fairness. Okay, but try not to miss them. It's not meant to fail you, the quizzes, meant to really push you to study, okay, to stay in touch. Okay, study tips. I will record every lecture, but, I know it's a 4th year. Maybe you know the way around, but I would say attend a lecture. Okay, don't treat it as a replacement for the class. And then try to understand as much as possible. I think maybe in the beginning when we talk about scanner or regular expression, we review NFA, DFA. These are something you already understand. Maybe you have not understood, but anyway, we'll see. But once we get to the parsing side, things will get a little bit more complicated. So I think it's really important for you to attend the classes. Ask questions for sure. Since we got a small class, I think it's really your advantage to ask me questions. And then take notes if you wish. Okay, GitHub. So this one here, I tell you what, I'm not 100% certain about this, but I think at some point, maybe at least for the projects, we may force you to somehow use the GitHub when you do the group work to actually checking your work on a regular basis, and then also at the same time going to submit for grading. That's something we want you to do. But I'll be writing precise instruction for you. Okay? Any one of you who has not been using GitHub? Everyone has a GitHub account? That's pretty good. Okay, nice. Okay, very good. Okay, I would say don't worry too much about this requirements over here just yet. Okay, if I really want you to create an account easier for grading, I'll let you know. But for now, since everybody got some GitHub, so that's fine. Okay, so right. Okay, so when you submit your work, you still gotta submit to the EECS account, regularly. Okay, academic integrity still apply. Okay, for every assignment and the projects. Okay. If you need any accommodation, please let me know, and then I will try to see what I can do. Okay. Okay. Any questions about how the course is going to be run before I get to the contents? Yes. Aha. Yeah. Java. Mm-hmm. I thought about iPhone. No, I'm joking. I'm joking. Yeah, yeah. Well, actually, it could be advantage for some of you since you just finished that, right? Oh, let's stay in Java. That's okay. Yeah. All right. But the ideas we learned about, the idea we learned about compilation, you'll find that about scanning, about parsing, about semantic analysis, you go across every language. For Python, for C#, for iPhone, for any language, they do have. So Java will be okay if everybody is comfortable. Yes? So we're going to use a tool called Antler. So, Antler. So that one is going to be, that will support many languages like a Python, also C#. I believe maybe C++ as well. But it also support Java. That's why I use Java. There's a tokenizer. There's also parser generator, everything. Yeah. Well, I will maybe in the first 1 or 2 weeks, I will talk a little bit more like theory. And then once we get to the point that you're ready to do some hands-on stuff, and then I will give you some resources. Yeah, maybe the assignment. Yeah. Oh, afterward, the assignments, okay, let me just show you once more. Okay, the assignments is only about 10% for 4 of them, so it's not really heavy, but I think it really can get you some experience. Oh, sorry. If I forget, please remind me. Okay. So the assignments, you got only 4 of them for 10% in total. So it's not really meant to be very heavy. So I would say try to use that as a preparation for your projects. Okay. I will try to finalize the write-up for the project, and I'll talk about it when it's ready. Definitely before the reading week. Okay. So you got enough time. Okay. All right, guys. Any questions? We okay? Okay. So, your immediately coming deadline would be quiz number 1. So that'd be January 20th. I'll usually talk about what would be covered 1 week before. For example, if you got the quiz number 1 next week, I'll talk about it today. So you got at least 1 week to think to know what to be studying. Okay, there should be no surprise. Okay, let's talk about compilation. Okay. Why compilation can be useful. And by the way, when I say reading over here, it's engineering a compiler version edition number 2. Okay, that's a textbook I'm talking about. So chapter number 1 we're going to cover today. Okay. So what is a compiler? The easiest way for you to think about compiler is software. Okay, and then it's going to automatically is really important, right? It's not manual. So once you have done the manual encoding of everything you need, you can then run this tool for as many times as you like. Okay, it's going to automatically either translate Some people also talk about transformation, so either way is okay. Okay, translate or transform something to something else, as general as that, as long as you know about the rules for both worlds. Okay, so let me talk about some terminology. So we talk about input, we talk about output. Also, sometimes we say source versus target. I might just use them interchangeably. Okay, I'm going to show you some diagram in just a moment. But if you look at this definition here, it tells you how powerful a compiler is. You can turn something which is written in one language into something else that's written in another language. And one language and another language, they do not have to be the same. For example, you might write a compiler to turn Java into SQL database, which is one example I want to show you today. Okay? Or you might turn, the more conventional use of compiler is you turn sounds like a programming language into machine executable code. For example, you might turn C code into MISP instructions. Okay? So that's a more conventional use. But what I really want you to pick up on this course is once you get a skill for compilation, you can turn anything into anything else, as long as you have a very clear understanding about the rules for both ends. Okay? Okay, let's go over this diagram very quickly. Okay? Because I think for lecture number 1, I just want to go over all the important terminology with you. Okay? Okay, so that's the overall overview for the compiler. Okay, okay, you can think about the compiler is over here. Okay, first of all, it's a software system, right? Somehow there'll be lots of job to be done in the compiler, but let's not worry about the internal workings just yet. Let's think about what's the context for the compiler. Okay, first of all, there will be an input program. For example, let's say Java or C, doesn't matter. Okay, and then once you pass that input program into the compiler, compiler will magically do some computations depending on how you defined the computation to be, and then it's going to generate something called output or target program. For example, it can be bytecode, for example, right? Or it could be from Java into SQL database, which I will give you more details when we talk about example. Okay, so now this is pretty well. You got input, you got output. Also, you got some black box over here, which you have to implement. But now what's really important is what kind of rule should you encode into your compiler? Okay, the input program here, for example, you can see in the case of Java, how does the compiler know about the syntax or know about the shape of the input program? That's something you have to define at the front end of compiler. Okay, so now whatever input you have to precisely define the language of the program. Let me give you a little bit of preview of what we're going to talk about. In 2001, you talk about different languages, right? The first level you talk about was regular language, and then you talk about context-free language. For example, these two, right? So these two languages will be something we're going to play with in this course quite a lot. Okay, I'll talk about it. Okay. So now you can think about the language here is more like a rule for the source. What should be the shape? And once you define this particular rule, you're going to encode it into the compiler. And in this case, Antler. So Antler allows you to specify what should be the grammar or what should be the token structure for your language, right? Input and output, both. Okay. But typically, you only have to specify the grammar for the input. For the output, you can just have a pretty printer. Okay, we'll get there. And then also you have the output and target language over here, and also you got to encode its knowledge over here. Okay, I would say mainly about meaning. And then we're going to talk about this word quite a lot, semantics. So this is a more formal way to talk about meaning. Semantics simply means meaning. So you're going to talk about semantics for the input. What's the semantics for the Java program? For example, when you have a for loop over here, integer I is assigned to 0, etc., right? And then you do something here. Let's say this. If I say, now I want you to define a compiler for Java to iPhone. Okay? If the input looks like the for loop, you definitely cannot just copy verbatim from for loop into IFO because there's no such concept about for loop in IFO. But you have something that has the same meaning. From loop. Did I talk about across? Yeah, okay, across, right? Exactly. Basically, think about the compiler. Once you think about abstractly, syntax is not really important. Well, it's important, but it's not so challenging. What's challenging is to think about how you can have semantics preserving transformation. Okay, that's something I'll also talk about. Semantics preserving transformation, which means your compiler, of course, in this course, we don't really ask you to formally prove the compiler. You only have to test it using some test cases. But you have to make sure it's really semantics in preserving. For example, if I give you a for loop in Java, you shouldn't just give me maybe like an if conditional without a loop in IFO, right? The meaning is not preserved. Okay. So that's why I say semantic domain for the input and also semantic domain for the output. Okay. So the domain may be the same or may not be the same. You may just want to do a compiler from Java to Java just to make it maybe a little bit more efficient, have some early exit. Or you simply got different domains, let's say Java to SQL database, they got different domains. Okay, one is object-oriented, the other one is relational. Okay. Oh, questions. How many of you has taken database class so far? Okay, that's good. Who has not? Okay, hopefully I wouldn't give you any disadvantage, but today when I do the example, I'll talk a little bit about database. I'll try to explain by using an example. Okay. But database is not required, just might be interesting. Because one common usage about compiler is to say, when you actually do your modeling, you don't do it necessarily on the at the SQL level. But when you do implementation, you want to do it at the SQL level. So now you have a gap. Okay, we'll talk about it. Okay. Guys, any question about the terms we talked about so far? We got input, output, we got source targets, we got compiler, we got semantic domain, and also we got encoding, right? Things like that, a little bit abstract. But eventually, you can think about by the every time when you kind of feeling that you're lost, think about this diagram over here. Okay, and also other diagram that we can talk about today. We'll talk about maybe flowcharts today. Okay, let's go to the next one. Semantic domain. Okay, it's basically about the context. Okay, which context are you talking about? Are you talking about context for OO, context for database, or context for predicates? Right? Maybe you want to build maybe a predicates to predicates. Maybe you want to just rewrite the predicates, right? You have a compiler for doing that. That's also possible. Okay. The source and target may be in different semantic domains, and also, okay, Java to SQL, and also maybe C procedural program to MISP, right? So these are different compilations. Right? All right. So as I said again, idea about compiler is extremely powerful. You can turn anything to anything else, really. That's almost true, except you have to be very clear to encode the rule for this anything here and also this anything else. As long as you can encode the rules for the shape for these two sides, the input and output, you can definitely build a compiler. And once you build a compiler, any arbitrary input satisfying the grammar for the input can be somehow processed and generate a corresponding output. It's guaranteed. So termination should be guaranteed, of course. So now I put a precondition here. As long as the following are clear about them. Okay, number one, the syntax should be very straightforward. Should be very clear to you. So for example, what keyword should you support? Maybe you want to have a keyword class. You want to have a keyword create. You want to have the keyword maybe across, etc. Okay. And you were going to specify the syntax using context-free grammar. Okay, we're going to do that maybe in week 2 or 3. Okay, we're going to review. Now, number 2 is the most challenging bit about the semantics. So once you actually parse your input into something that's intermediate, we'll talk a little bit more about intermediate later. You can think about what a compiler will do eventually is about doing transformation between trees, parse trees. In 2001, you talk about parse trees, right? Compiler, oh, do you know what a parse tree is? Does it ring the bell? Did you take 2001? Okay. Okay, sure. Oh, we'll review that. Basically, for those of you who still remember what a parse tree is, think about a parse tree is simply a tree that's actually satisfied the corresponding grammar. Okay? Once you get a parse tree here, you can transform the tree for as many times as you like until you're happy. And then for that final tree that you're happy with, you can pretty print it into the target program. Okay, we'll get to that form. Okay, I'm just keep saying something that I'm going to talk about. Okay, syntax and semantics. You might be struggling a little bit in the beginning of the course about syntax, but what you realize very soon, semantics is really the part that's difficult, that's challenging. Analogy, when you first studied the first year course, you found that just to get my code to compile is very challenging, right? But once you get through the first month, your code will start compiling, no problem. But you found that now I keep getting index out of bound exception. Well, null pointer exception. They are more semantical. Okay, that's kind of analogy. Okay, so now construction of a compiler is a very big software system. You can easily have maybe tens of classes to actually solve them. Okay, so you should really try to obey software engineering principles. We'll try to cover some when we get to them. Okay. Things like maybe modularity, you should have many classes with inheritance or client-supplier relationship, and also information hiding. Okay. Single choice principle, do you still remember what they are? Okay, single choice principle. Some design patterns, we will actually see some example for composite. And the way to really perform operations on composite will be visitor. So when we do the Antler tool, we'll actually see some nice use of the visitor pattern. Okay, regression testing at different levels. As I said, for this course, we don't really require some formal proofs for the compiler for its correctness. What we ask you to do is to do some unit testing, testing the methods in your Java compiler, and also to do some acceptance testing, like input to output, right? Testing, okay? Just to test your compiler before you submit. Okay, so now let's talk about infrastructure, okay? We have, so now I'm trying to show you, oh, by the way, you can see the difference between the diagram, right? Before I was mainly focusing on the surrounding context for the compiler. But now we got source program, we got target program. Now I'm showing more details about infrastructure for the box that you're going to implement. I'm revealing this magic, demystify the box. The first one is still pretty simple. Think about we have some front end, we have some back end. Between them, we got some IR, standing for intermediate representation. Okay, I will see, today we may not see so many intermediate representation example, but we'll see them maybe a little bit later in the course. Okay, okay, the front end, I'll also go to the diagram in just a moment. A front end, once you pass a source program to the front end, somehow you have to talk about what's the shape for the front end. Maybe specify the grammar or the token structure in the front end. And also, you're going to transform from the source into IR. Okay? Maybe I can do a little bit example together with you. Okay, let me see what I should do here. Okay, good. Okay, for now, you don't have to worry about the question I posed there. Okay, let's talk about something just for example. So let's say over here, you can think about something like this. If I have, let's say, the input program is simply like a Java, okay? And then over here, as I will simply say, is a very trivial example, but hopefully I can illustrate something. If I say I is assigned to 3, we pretty much know what it means, okay? So now you're going to pass that to the front end of the compiler. Somehow the front end is going to tell you what the grammar is, what's going to be a structure for the Java program. For example, one of the grammar rules is to say variable followed by equal sign and followed by some expression for integer, for example, right? And now, for the grammar over here, we're going to see, okay, grammar and token structure. Okay, so these are the two things you have to specify. Okay, we'll give you a little bit more details. And then what can be the intermediate formats? I would tend to think about intermediate formats like a tree, okay? You can think about, I can somehow turn this guy over here into like a tree structure. For example, I can say assignments. For example, like let's say there's a class called assignments, okay? Maybe I should capitalize that. Let's say there's a Java class called assignments, and I'm creating a runtime instance of that. And the assignments usually should have both ends, right? So you should have maybe one end is called variable, so there may be another class called variable. And the variable has one attribute, maybe for the name of the variable. In that case, that would be just the string I over here. And then the right-hand side of the assignment can not just number. You should really define as general as possible. It could be just some expression, right? So I can put expression over here, and then maybe somehow it will be integer expression, and then eventually it will be integer literal, which will be just 3. So this is more like intermediate formats. What's nice about this is this particular guy here, when you look at the tree, you wouldn't really know it's actually transformed from a Java program, right? What I meant by was, let's say this. If I somehow have, and let's say this is input number 1, okay? Input number 1. If I just got another input over here, let's say, let's talk about iPhone, right? The syntax will be different. I might just say I colon equals 3. Syntactically, I1 and I2 are different syntactically, right? One is using equal sign, the other one is using colon equal. But now, if once I pass to the front end of the compiler, am I going to get the same tree? Yes, because the same tree. Because at the conceptual level, we all talk about assignments, and also we got variable. Somehow, colon equal versus equal are not relevant once you get to intermediate formats. Okay? Yeah, that's I just want to give some intuition in the first class. We'll see a little bit more later. Okay? So once you get the intermediate formats, you're just going to backend. Backend, I wouldn't give you too much information today. We'll talk about it later in the lecture. Intermediate format simply means you're going to do a little bit more further processing. Okay? Just further processing about the intermediate formats, and then eventually you can generate a target program. For example, let's say this. Let's say I'm happy with this tree over here, so now I can easily pretty print it into anything I like. Maybe I simply want to say assign, that's the output, assign 3 to I. So that means I can easily build a compiler which will compile from iPhone code into English description about what the program should do. Right? That's also a compiler I can do. Once I get intermediate format over there, I can just pretty print it in any way I like. Okay? Guys, are we okay? Okay. Now, let's talk about this particular question here. So now this question will flow naturally to this. Let me just open up. Let me just cut this. Okay, we'll talk about intermediate representation, right? How many intermediate representations do you think that will be necessary to build a number of compilers? Let's say we want to build 4 compilers. Not really like a full syntax for Java. Let's say some subset of the language. Let's say Java to C, iPhone to C, Java to Python, and also iPhone to Python. Think about conceptually how many paradigms we are really talking about. Let's talk about naive solution. Okay, so let's talk about naive solution. And then let's agree. Let me lay out the naive solution and let's agree that it's bad. And let's see how we can optimize it. Okay? Naively, this is what we can think about. Okay? So we got 1, 2, 3, and 4. 4 different languages. Okay? Let's say I got 1 intermediate representation formats for Java and 1 for iPhone. I also got another one for C. I got another one for Python. Let's say, okay, that's a naive solution. Okay, how do I build this particular compiler accordingly? So what I will do is I can say I got my Java program over here, and then I'm gonna pass it to the front end, and I'll turn that into the intermediate representation for Java. And then, since I'm gonna target language will be to C, I will transform that into the intermediate representation of C. And then, once I get that, I can pretty print it into a C program. Okay, that's a layout for a compiler. Okay, just do one more. Okay, I can also say, okay, now let's say I got my iPhone source program over here, and then I can transform that, I can compile that into intermediate representation for IFO. And then now the target is, again, C. Intermediate representation for C, and then to C. Right? Any criticism? I tell you what, it will work, but may not be a good design. Yeah. Yeah, you can think about, well, okay, since I haven't really spoken too much about intermediate representation, you can think about intermediate representation as more like a summary of features in the language. For example, what would be the intermediate representation for Java? You'll be very Java specific, which means for a Java program, what do you have? You have a class, you got declaration of variables, and also you got methods, mutator, accessor, etc. Very Java specific. What would be the intermediate representation for IFO, for example, before I point to you? So it would be, we got, let's say, also we got class, also we got create class, and also we got commands. In IFO, we don't really have constructor. You only got commands. You only declare commands under the create clause to make them constructor, right? And also you got cross loop, and you also got commands, queries, attribute, etc. It's not exactly the same terminology, even though you do have some similarity between the languages. Question?
So Java, IFO, and Python pretty much offer the same thing that they're all offering.
That's true. Okay.
We'll see it's not offering that. So you'll have some differences there. You could potentially solve it into one IR, but you could do it with two IRs.
2 IRs. Okay, that's good. Okay. That's good. Basically, what you're saying is somehow IFO, Java, and Python, they all support object-oriented features. Maybe in one case you call it feature, in another case you call it attribute. Doesn't matter, right? They are basically just about variable with some type. Exactly, yeah. So the concept, you definitely got polymorphism, you got context object, and etc. Right? That's true. Okay, yeah, C is a completely different paradigm. Okay, questions? Yes, go ahead. Okay, so I think for IR, how expressive the IR should be depends on what's really the thing you need. Let's say when we talk about, okay, how many Java features should be covered, right? Language features. It depends. Depends on what's kind of the assumption you make on the Java. For example, when we actually update the Java compiler, for example, before Java 1.5, I believe, before 1.5 or prior to some version, they don't have the syntax for generics. Yeah, in that case, if you write generics, the compiler wouldn't work. But that means you got to extend the compiler a little bit. Okay, so how many features you should really include in the intermediate representation really depends on what kind of assumption you make about a source language. That's why I said you should really have a very clear knowledge about the syntax and also semantics about it. Okay, let's go back to Ash's point. That's pretty good. That's pretty true. My thinking may be slightly different from yours, slightly. I also need 2 IRs. Okay, this is how I think of it. Okay, let me just copy that and then I'll just make a new one. Okay, I definitely agree with you. Java here, IFO and Python, all of them support object orientation, whereas C is purely procedural. I agree. That's no problem. Okay. However, I was looking at slightly differently. I kind of look at the paradigms for the source and the source and the target. If you look at the source for these all the 4 compilers, basically they're all OO. So that means if I can get the intermediate representation for OO, which means in this particular IR, you should really cover all the essential concept about OO. Context object, method call, methods, and also polymorphism, inheritance, etc. Right? And then over here, this is where we disagree a little bit, not slightly different. Okay, over here, I'll think about it. Given that this guy here is more like a OO, so now here, if I can make the assumption that when you want to generate the code, of course the meaning has to be preserved. What I can do is like this. I would say procedural, in the sense that whenever I'm trying to generate a target program, I'm trying to use a procedural concept to implement OO myself. Okay, and then the Python here, even though it supports OO, but I can just use the procedural subset of the Python to implement. Yes. Yeah, you can also still get. Well, the problem is if you only got one IR, somehow C wouldn't fit for that.
No, so well, it would actually, because it doesn't, technically it's not all, but you can simulate it. You don't really have information.
Okay. But the problem is this. Yeah. If you got one intermediate representation, let's say just for procedure, right? That's kind of what they are in common for sure, right? Somehow C doesn't support. Yeah, that may not be bad. Okay, what you're saying is like this. If you only got, okay, let me just lay out this precisely, and then we'll talk about it. I wouldn't say that's not. I wouldn't say that's pretty good. Let me write it down. Java and IFO, they can all be compiled into this particular IR for OO, first of all, right? And now, when you actually want to generate the corresponding one for Python, that one should be quite easy because Python definitely got a native support for OO. But now the problem is, when you want to implement this particular, I would say pretty printing, okay, into C, this will actually require work that's not just pretty printing. When I say pretty printing, which means you don't have to do too much, you don't have to encode any implementation strategy. You just write it out. But, well, actually, for example, let's say if the input simply got inheritance, somehow you want to have some strategy about putting records together and keep some, maybe do some little bit of transformation to make it work, right? So that's not as easy as like a pretty printing. When I say easy pretty printing, simply means you go through the tree, just one pass, and then write it out. Yeah. So I would say that's not wrong. It's just inconvenient for this particular green arrow. Okay?
I have a couple questions. So we're using one for Java and iPhone, and there are like things in Java that are not supported in iPhone, like the synchronization.
Yeah, in that case, maybe when you compile, yeah, I agree. So so that means you want to make sure, yeah, when you define this particular IR for OO, it should be accommodating enough so that any peculiar feature you have in Java, either you can simulate it or you have to assume it doesn't exist in your input program.
Okay, so my second question, if you can do that, then why not use one for all of them and then do conditions for each one?
That may not be a very good. That may not be a very good design over here. Whenever you got so many conditional structure in your program that can violate some principle. Yeah, so I think this example here is just to get some idea about what are the possible mappings you may define. So I think yeah, okay, yeah. Yeah, I kind of try to put it quite a little bit vague just to stimulate some discussion. That's no problem, okay? But I would say, for example, if I do give you this problem here for the project, but I'm not going to do that, right? So what you want to think about is to think about what could be a good design, right? Yeah?
You can still use OO, just assume what the specific features we're most likely going to be using and just add it.
Yeah, that's okay. So that's why it'll be a design choice you have to make when you define the compiler. So in the manual of your compiler, you're going to say, for this particular compiler, I support the following syntax precisely. You shouldn't, if let's say my compiler doesn't support, let's say the create clause, for example, for the iPhone. So if you read, the user do have that particular clause in the iPhone program, you should really give it an error to say it's not supported. Okay.
I have one question regarding
Yeah.
before when you were saying like compiler is anything to anything.
Yes.
I have an issue with that because what if you like,
Oh, there's a precondition there, right? Assuming that you know precisely what anything is.
still
Mm-hmm.
you can't translate, like let's say you can't translate a Turing complete language to a non-Turing complete language. Like how would you translate language like Java to HTML? Like you could get an HTML thing out of it, but it wouldn't do the same thing.
Yeah, so I believe that one there is actually covered here. Okay. Although I'm not too sure if that's precisely covered. Yeah. Maybe I should have made my wording a little bit more carefully. You guys are good. I like it. Okay, let me just go back to there. Okay, when I say semantics, programmable as mapping functions, you're more talking about how can I map from one into another. For example, how do you, for example, compile Java into HTML? In this case, I guess maybe not. Because when you think about the, okay, syntax is easy. Define a grammar for Java. Okay, guys, let me make this one clear to everybody. Okay, and now I'll come back here to just to give you my thoughts to this, and then we can go to the next one. That's good. So what you guys were talking about was like this. If you want to have a Java to HTML compiler, is that doable? I would say only in the beginning phase. Okay, you can definitely have maybe syntax and also token. I'll just I'll talk a little bit more precisely about what they really mean a little bit later. Okay, you definitely can have Java, and then also eventually you can also define something. You can define things in isolation, put them together eventually. You also got this maybe here. You also got some intermediate form over here. Eventually you're gonna pretty print into HTML. Okay, and then some pretty printing. But now the problem is, how do you go from here into here? Right? Because I don't think HTML got any like a functions or, yeah, it's more like a markup language, isn't it? Yeah, so I don't think that's possible, right? Mm-hmm. True, true, yeah. So the assumption is really important to think about whether the source is more expressive than the targets. If that's the case, you may have to restrict certain subset, or just restrict that to empty set, right? This cannot be possible. Yeah, so, okay, it's very good. So now, guys, when you read the slides, I think this guy, programmable mapping function, which means you're able to come up with mapping functions. You can find a corresponding concept between the source and the targets. Okay, questions? Yes.
I'm just kind of curious.
Yes.
Do compiler be the opposite of this whole process?
So is it decompiler?
Yeah.
Oh, that's a good question. No. Yeah, go ahead.
You can like convert DFA into Java code, but you can go from Java to DFA.
I think he's more talking about, let me try to think. I believe you, okay, if you got a .class file for your Java code, right?
Well, first of all, those are super easy because class files are very detailed. I mean, you can even decompile C. You can decompile bytecode. There's
I believe that's still like a compiler, right? Because again, it will still be compilation because you're simply given something and turn it into something else. As long as you're trying to implement this purpose, you're doing compiler.
Okay, so it's another compiler.
It's another compiler, yeah. Maybe given Java code, given Java bytecode, you want to just present one possible way that will be translated into that particular bytecode. Yeah, yes. Okay. Yeah, compilation is very general concept, very general. Yeah. Okay, good. Oh, okay. Let me just okay. You guys got a very good solution here, but I just want to mention what I thought in mind. Okay. But we can maybe try to look a little bit more details later. Okay, once we know much more about intermediate representation. What I was thinking in my mind was something like this. I got Java, and then I got iPhone. And then one possible way, okay, I'll just say one possible. I'm not saying that's a sample solution, right? One possible way. to do this is I can say the following. They will be compiled into intermediate representation for OO. That will be supported, right? And then somehow, I'm going to somehow have some strategy for compilation, okay? Some strategy of using procedural to implement OO. So I can convert that into the intermediate representation for procedural. And then after that, I can generate as many procedural as I like. In this case, I can just give the procedural subset for Python. Okay, I can also give the procedural subset for Java. It's like using the procedural part of Java to implement the OO part of Java, right? That's also possible, right? That's just another strategy, Java and also IFO, and also Python, okay, and C. Anyway, we'll talk about the structure a little bit later, okay, once we get more knowledge. Okay, good. Okay, front end, back end, and then, okay, intermediate representation. Okay, optimizer, okay. The optimizer is basically about once you get your intermediate representation, you may want to tune, you may want to transform the trees for as many times as you like for different purposes. Okay, the conventional purpose is more like about to have to improve the runtime performance. Right? We do have one example from the textbook. We can take a look. But I would say for your projects, you may want to do optimization not just for the performance, maybe more for the design. Maybe I give you some language, and then you want to really try to come up with the optimal design possible. Not really the absolute optimal, but just try to improve its design. That's also possible. Okay. Okay, let's see. Okay. There's something I want to go over quickly over here. Okay. Again, so this will be, again, this part here is the internal components for the compiler. Okay, you got a front end, you got some intermediate representation. You might have to transform your intermediate representation to different intermediate representation, and then eventually you can generate a target program, right? Okay, so now the question is, let's say this. This is a very important question to answer that has to do with the correctness of the compiler. Okay, let's see this. This is my source. This is my targets. Okay. If the user gives you this particular input source, how can they rely on the behavior of the target program? How do they know whatever they really got is really going to faithfully respect the behavior for the source program? For example, let's say when you do 3311, you may have noticed that IFO code has been compiled into C. We kind of assume that the compiler is going to faithfully transform the IFO concept into C code. But how do you know that's really correct? So what will be the factors over here, according to this diagram? Yeah. Yeah, that's definitely one way to test. It's more like an acceptance test, right? Just input and output. Okay. So it could be like you may simply say, I got input program number 1. Okay. Input program number 1, and make sure that's actually output program number 1, right? And also input program number 2 and output program number 2. I'm more talking about what are the factors you have to look after when you develop your compiler. Okay, let me just tell you the answer quickly. Okay, if you look at the diagram here, first of all, this part over here is really important. Okay, when you have your source program and then you want to compile that into the very first intermediate representation, you want to make sure that process there reassign a correct meaning to your input source. Okay? The input to the first IR must be accurate. Okay, that's number 1. That's the very first one you're trying to do. Okay, the green one. Okay? And then after that, in the intermediate stage, you might go from IR, let me call this IR1. From IR1 to IR2, and also IR2 to IR3, right? You may do as many as you like. Eventually go to IR, maybe N, the last one. Okay, you want to make sure every one of them is so-called semantics preserving. Okay, make sure they preserve the meaning. So that's number 2. What will be the final one? Well, according to the diagram, what am I missing here? Backend, which means once you get to this particular IRN, you want to make sure IRN is more like a tree at the runtime. You want to make sure the pretty printing you're trying to do into the target program is also faithful. Okay, IRN into the target. Okay, this one is also very important. So every transformation you do, you want to have a way to justify it. Okay, if any stage goes wrong, then your output program is not going to be correct. Okay, conceptually. Right. All right. Any question about this? We okay? Yeah. Okay. How do we test that? 2 tests you can do. Okay, 2. Number 1, you can do some input source program and also output acceptance test. Because all of you have taken 3311, let me make some analogy. Remember in 3311, when we do the ETF, we don't care what classes you created, right? We only care whether the input we give to you can be turned into the output. So that's input-output. So that's the acceptance test. Okay, number 1. End-to-end. But number 2 is also very important. So let's say from the source program into the first IR, that's kind of internal to your program. So you cannot just do acceptance test. You got to do some unit testing. Okay. So now from for number 1 and number 2 and also number 3 as well, right? So that should be some unit testing. Because you have to know the internal of your program. Yeah. Because in your case, you might define certain method signature that only you as a developer know about, then you have to do unit testing. Okay. Yeah. Okay. So there are 2 types kind of test cases you should do. Okay. Yeah. Of course, in theory, you only choose to do 1. If you're lucky enough, you just get it right. However, to really, I wouldn't suggest you do that, right? Because there might be so many intermediate transformation. You may want to do some small, you want to do some good number of test cases for each one of them. So you can have more assurance that overall it's going to work. Okay. Yeah. So what do you mean, the second one? Yeah, the unit testing basically just to say, when you do from IR1 to IR2, you just want to make sure the transformation you have written can really successfully transform, right? Yes, it's more about whether, given this particular tree, am I going to get another tree of the proper shape? Yeah, something like that. Oh, no, actually, no, that's what I meant. So for number 2 over there, it's really about to go from one tree to another. Have you actually changed the tree structure properly? As you will see the tree structure rewriting right now. Okay, right away. Exactly, yeah. Basically testing for the tree transformation. Yeah.
And the first one you just giving input and output.
Input and output, yeah. I think both are important. But you don't want to be so lazy to do 1 only. Because when the project is so big, you don't want to do 1 right away. It may be hard to debug. You don't necessarily know which part has got bug. So you may want to do for each transformation.
Let's say that I write the compiler goes from Java to C++.
Yeah.
But I use somebody else's compiler. We should not get the same result. Or should we get the same result?
Oh, okay, interesting. You're saying let's say we got some, let's say, shouldn't be the same. Okay, interesting. It may be the same, it may not be the same. How about that? There's no guarantee. Okay, let me just talk about it. Okay, good question. Let's say, Mahood, you actually write a Java. Let's say we got Java program, and also, okay. Let's say foo.java. Okay, the same Java program. Let's say we got 2 Java compiler. And 1 Java compiler is written by Mahood. I'll put N here. Okay? let's say independently we ask Ash to do another one. Okay, A. I can find another one. How about Sammy? Okay. The purpose for the three compilers are the same, from Java to C++. Okay. Assuming that all the three compilers are correct, meaning that it's semantics preserving. Okay. And now foo.java over here, if you try to supply that as input to all three of them, they're gonna have maybe maybe let's say foo. Sorry, what's the extension for C++? CPP. Thank you. Foo1, foo2.cpp, and also foo3.cpp. Okay. They may not be syntactically identical if you do a very superficial diff between them. However, semantically, they should be the same. Assuming that assuming that a foo.java is complicated enough. For example, if foo.java is simply, let's say, printing a hello world, you don't have that many possibilities, right? But if that's very complicated, let's say maybe like a static analyzer, for example, right? In that case, maybe foo1, foo2, foo3 could be very different, depending on what's the encoding inside the compiler. Okay, let me just make a remark and then I'll take questions. Yeah, let me just write down the remark. Okay. Maybe syntactically different. Syntactically different means if you do a diff, they're simply different text, different sequence of characters. Number two, should be semantically the same. Okay, questions?
Say one of the compilers also doesn't run optimizations, also may actually be different. It may have done some.
Yeah, exactly. But since we talk about input and output, so the output will all be C++, right?
No, but even I'm saying, even at the IR level, when you abstract the syntax out, they may still be different because one of the compilers may have done some optimization.
True.
Changed
True.
like the for loop,
Yeah.
split loops, like unroll.
Absolutely. Actually, we're going to see some optimization in just a moment. But the point is, given different compiler, even though their purpose is the same, but it really depends on who the implementer is. They might do different optimization. Okay, good. All right. Okay, let's do a very simple optimization example, a very simple one. Okay, so these are the three things that we talk about. Okay, all right, and they are necessary and also sufficient for justifying the soundness of compiler. Okay. Again, for this course, the best you can do, testing. Okay, that's a very practical solution to that. Okay. Okay, so now I'm going to give you two example compilers. We might not be able to cover the second one. I can do that in the beginning of Wednesday, but at least we can do the first one. Okay, the first one can help us also introduce many terms. Okay, the first compiler is more like a very conventional, meaning that we get, let's say we're getting a C-like program, turn that into machine executable instruction, like a MISP, for example, right? That's in chapter number 1. I'll give you some flavor of it, but you can definitely try to read it, okay, on the textbook. Okay, so now in this case, source and target, they're at different levels of abstraction. One is definitely lower, the other one is higher. Okay. Okay, and somehow, of course, we wouldn't call C a specification language. You wouldn't call it, but if you call it about relative, either so definitely C is higher than MISP. If you really give it a chance to think in terms of C versus in terms of assembly, I guess you might just opt for C, right? That's what I'll hold for. Okay, good. I'll talk about this diagram quickly, okay? And then just tell you the terms, and then we'll talk about individually each one of them. This diagram is from the textbook, okay? First of all, you can see in the intermediate stage, we got different, we get a number of optimizations, okay? You can have as many as you like, okay? And for the back end, we got, since our goal is to generate some machine executable instructions. It can be selecting the instructions, scheduling instruction, or allocating the registry, okay? We don't really talk about it for this lecture, okay? We'll talk about it a little bit later. It should be a little bit boring for now, okay? What I want to give you a little more example is about scanner and parser, okay? So these are interesting, okay? Basically, scanner and parser, They are basically dealing with the same input program, but at different levels of abstraction. Okay, I'll give you some analogy later. Okay, so at least you should know what the difference is between scanner and parser. Okay, there's another diagram I want to show you. Okay, so now let's go over this diagram quickly. Okay, sorry, that's a bit small. Okay. Basically, for every compiler you do, there are 3 kinds of analysis you have to do eventually. Okay, we'll talk about each one of them. The first one is called lexical analysis, which means you're more focusing on the words, individual words. Let's say you're talking about English essay. Okay, lexical analysis is only checking for spelling mistakes. Only that. Okay. Basically, you're talking about the source program as a sequence of characters. Okay, and then you're gonna implement some scanner. So we talk about how you can do scanner implementation theoretically on the paper, and also we can generate scanner for free by using Antler. Okay, we'll do both. And then once you have got a scanner, what you will do is it's going to group individual character into valid tokens, like individual words. Think in this way. If given the program here, the way the scanner sees the input is like individual words. Individual characters, like that. And then once the scanner has processed this particular sequence of characters, it's going to generate a sequence of valid tokens. It's more like this. Right? They can group words together. Okay? We'll give you some example about tokens in just a moment. Okay? Let me just talk about all the 3. And then once you got a sequence of tokens over here, you're going to give that to something called parser. So now from the parser's point of view, it doesn't worry about individual characters. It more worry about the structure of composing the tokens. So analogy would be sentences are like the parser, basically. So the parser is more, so you can think about here, scanner is going to turn characters, okay, let me make it a bit smaller. Turn characters into words. And then for the parser, it's going to turn words into sentences. Okay? So now, any output from the parser over here, any output from here is guaranteed to be correct in 2 respects. Number 1, valid tokens, which means no spelling mistakes. And also, it's going to be valid, I would say, composition of tokens. Okay. And it's more like a valid sentences. But now, let's say you're given a piece of writing. If I tell you there's no grammatical mistake, there's no spelling mistake, is it good enough? No. If that's the case, maybe everybody should really receive like 100%, right, for the 3311 exam. Assuming that if nobody make any spelling mistake, nobody make any grammatical mistake, but maybe just answering the wrong answer, right? Which means semantics is really important. Raymond.
We're right now in semantic analysis.
Oh, we'll get there. So I'm just talking about the flow. You start with a sequence of characters, and then the scanner is going to turn that into valid tokens. Yeah.
The question is for number 2.
Yes.
Would that not be like semantic, like analyzing semantics?
Which one?
Point number 2.
Point number 2, no, it's not. Point number 2 basically is just doing some, just make sure the way you compose the tokens together is actually right. I'll give you one example.
Checking for grammar and
Yeah.
stuff.
Yeah. I keep making it up. Not very good example. No spelling mistake, no grammatical mistake. Agree? Doesn't make any sense. Yeah. Or I eat exam. That's also fine, right? Okay, it doesn't make sense. Okay, semantic analysis is really important.
But those 2 would pass the syntax.
Yeah, they will pass definitely the lexical analysis. They will also pass the syntactic analysis. Yeah, that's why it's called context-free. which means we don't worry about the context when you talk about exam, usually about writing the exam, not to eat something, right? You talk about two different contexts that cannot be grouped together, right?
So if you write play IXM, it won't pass.
Okay, how about, okay, let me make it very clear to you. Assuming that I got a compiler, right? If I got these two, of course, if your compiler accepts that, it is a problem, right? They should definitely pass the scanner because I is spelled correctly. Play is spelled correctly. Exam is spelled correctly. Okay? They should also pass the parser because I got subjects, followed by verb, followed by noun. That's definitely a valid context-free grammar rule. However, semantic analysis should now look at the context of talking about it. When you say play, what should really go after play? Maybe play basketball, play guitar, play iPhone. Sure, if you want to make it the rule of your command, then no problem. Yeah. Anyway, you see my point, right? Yeah. So now, very similar. So once we maybe in the beginning we gotta make sure you build a foundation for scanner and parser, especially parser. You might find it challenging, but I can tell the real challenge really is the semantic analysis because you really want to be clear about the meaning. For example, if I simply give you the project to say, now write a compiler from C into HTML, use your example, right? It might be very exciting to actually build the grammar for C, but as soon as you get to the semantic analysis part, you find that it's just not possible, right? There's no corresponding concept, right? All right, good. Yep, so again, we'll definitely talk about every one of them a little bit later. Oh, what would be one type of semantic analysis? Type checking, right? For example, if I give you a Java program class, let's say, let me give you a different example. How about this? Let's say we'll talk about Java compiler. So now the example would be different kind of analysis. So let's say we have a Java compiler, for example. Okay. First example would be if we have foo Is that okay? Are you sure? Yeah, that's intentional. It's not a typo, guys. It's intentional, right? You can see apparently this is not going to pass even the scanner, okay? Try this on Eclipse, you will see, okay? Oh, by the way, in Eclipse, you're going to tell you it's an invalid token. They use the word token. If you ever wonder about what a token is, this is what we're talking about, okay? Invalid tokens. Oh, you don't have to. You know, actually, I tell you what, it doesn't matter. When you talk about should that be private or public, it's more like semantic, right? But now in this case, it just doesn't satisfy the token, right? Oh, I beg your pardon. I made a mistake. Sorry about that. Okay. Let me take it back. This is actually, okay. If you don't mind, can I just wipe out this example? I'll rewrite it. Okay. It turns out this is not the invalid token. It's actually invalid grammar. It doesn't satisfy the grammar. Okay. Okay. Let me do it again. Sorry about that. Okay. Let me do a proper example for you. Sorry. Okay. Let's say the first one. Class. Okay, I think that's more appropriate. Okay, this one here will be invalid token because you cannot have, I believe you cannot have any identifier starting with some invalid, like a symbol. Like a, yes, yeah, something like that, yeah. I didn't memorize the rule, so I guess something like that. You can confirm with me, okay? So this will be invalid tokens. So this is like a invalid token. Okay, invalid token for identifier. Okay, let me go back to the example I just talked about. Okay, let's talk about this one here. Let's say now I have class, and then let's say foo. This is definitely a valid token. Okay, and then now I do the following. Let's say I do parenthesis so this will be one example where every individual token is fine, because there is definitely a word called class in Java vocabulary. Definitely identifier, definitely opening brackets, definitely int, like a special type, like a keyword, also a semicolon, also we got closing parenthesis. Individually they are fine. Okay, so this will pass the scanner. But now the problem is when you pass the scanner, now I got a sequence of tokens like this. When you put them together, you're going to have some trouble with the parser, because now you can see apparently over here, this opening curly brackets does not match with this particular closing parenthesis, right? They don't match. Parser error. Okay, good. Question?
Should we say it doesn't match, or should we say we can't find the closing bracket?
Yeah, something like that. I think definitely if you look through the grammar for that particular language, it will tell you whenever you want to define a class, you should definitely start with, okay, you can think about the grammars like this. Let me go a little bit further. Okay, for this particular one, when you define a Java grammar, it looks like something like this. You will start with the token for the class, followed by some identifier token, and then followed by left brackets. And then over here, I'm going to say body of class, and then followed by the right brackets. Okay, I intentionally to write this particular rule in a single line, because as far as the compiler is concerned, new line or quiet spaces usually don't matter. Doesn't really matter. Okay, what I'm saying is, in order for the program to be a valid class, number one, there should be a token that's spelled correctly called class, followed by some identifier, and the way you specify identifier is by using some like a regular expression conceptually. Okay, and then you have to be followed by another curly brackets, and then you should have a matching curly bracket somehow at the end. So now inside over here, this is categorically different. It's not tokens. It's something called non-terminal. Okay. Maybe back in 2001, maybe when they talk about context-free grammar, there's a difference between terminals versus non-terminal. Okay, we'll review that for sure. Terminal means that's it for the recursion. Non-terminal means you may derive further for as arbitrarily as you like. Okay, yeah. And over here, that will be just non-terminal. Non-terminal. Okay, I'll take question and then I'll do one more example. Yes.
It first looks for the closing bracket at the end, or does it go into the body?
Yeah, I think I'll leave the detail a little bit later. Somehow, when we talk about parsing, we're going to look at parsing at different level, maybe top down or bottom up. But if they're going to follow the same rule, the idea would be, if I given this particular program, am I going to be able to build a tree, parse tree from the program? Okay, I'll leave that a little bit unspecified right now. Okay, yeah, questions?
I have the same.
Yeah, so sorry, bear with me. So since we haven't talked about parsing just yet, maybe we'll get there. Okay, but okay, let's do one more. Okay, I want to give you one more example where we got basically. Oh, I got another question for you. Okay, how about we do two more examples and then we're done? Okay. Do you believe this particular guy should be a token error or parsing error or semantic error? question for you. Class followed by A. And then I'm going to do the following. Token error or token error or the parsing error. If you believe there's a token error, tell me which token is spelled wrong. Huh? In it maybe just identifier. You know what? I wouldn't mind the following. If you okay. Let me change that a little bit. Okay. Would you change your answer? Would you? It's a parsing grammar error. Okay? Syntax error, that's the same. Grammar error, syntax error, they're the same. So token error is easy, as long as individually tokens are not spelled wrong. Okay? You definitely get a token for identifier, for class. A token for identifier, a token for this, token for that, and also for colon. But now, in Java, the way you declare a variable is not following this order. That's iPhone, right? That's grammar rule for iPhone. Okay? So somehow, the way you compose compositions of tokens for variable declaration is in the wrong order. Okay, just one more, please. Just one more. Class A, and then, okay, I'll talk about single class, right? It's a simple one. Token error, parsing error, or semantic error. Semantic error. Why would you think that's semantic error? So in this case, apparently, okay, let me tell you exactly how it's going to work. At a scatter level, this is a valid token. This is a valid token. Valid token, valid, 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 and valid. Okay? Class followed by identifier, followed by this, and followed by that. The way you put them together is actually okay. Okay, so now the problem is, if you have identifier as the type, you better refer to a known class. Does B exist? No. No, because I talk about this is the only program, right? Okay, yeah, maybe you didn't catch that part. So that's a semantic error. Unknown class. Yeah, I think it used to be that this course has a prerequisite called 3303, something like that, like programming languages, but it's no longer the case. I'll try to give you some knowledge about programming languages as well, as we talk about this, right? Again, today, final words, know about the token error, parsing error, and semantic error, and then we'll continue with this, okay? Can I just ask you one more